Well, hello everybody. Here's what you missed when we covered section 1-6. There's a lot of items on this page, but on a piece of good news, I didn't get through them all. I didn't have to give back homework quizzes because we did not quiz the time before. I did answer questions on section 1-5, but we did not do the pairs check or the quiz. You missed a pretty tough lesson. A lot of notation. The concept itself over and and or statements isn't very tough, but I introduced to you interval notation. So you should have your class example sheet in front of you. Just follow along with me and let's see what we can do. There are the answers to your Day 5 assignment over section 1-5. You can always pause the video and check last time's worksheet. Make sure you know what you're doing. But there's what the answer should have looked like. But let me get to the meat of the lesson. You should have in front of you the class example sheet that I need you to follow along with. What I need to do first with you for the first 5 minutes here or so is I need to show you a new notation. Last time in class we talked about set builder notation with those cool parentheses at A, that bar, that A greater than 3. Remember, it's read like this: the set of all numbers A such that A is greater than 3. Well, let me show you what this looks like in what we call interval notation. I like interval notation better, to be truthful. That's what I have my calculus kids use. So let's look at the graph of this first. A is greater than 3. I would have an open dot on 3, and I would have everything going to the right. In interval notation, an open dot is equal to a parenthesis, and a closed dot is equal to a bracket. So here's what this same thing looks like in interval notation. I want all the numbers greater than 3, but not including 3. So here's what I'm going to have. I'm going to have a 3 with a parenthesis on there. To show all the numbers greater than 3, I use to infinity. The infinity symbols will always get a parenthesis because infinity is not a number that you can include. It goes on forever and ever and ever. Here's your number 2. I got A such that A is less than or equal to 3. So I'd have a closed dot on 3, and I'd have everything to the left. That's what that part looks like. In interval notation, it would look like this. I've got the big time negative numbers out this way, but I'm going to go to the right until I get to 3. Whenever you list interval notation, you always list the least number first. So since there is no n to the left, here's what it looks like in interval notation. I got parenthesis negative infinity. This just shows that to the left, I'm going to get all the negative numbers that I want to work with. Comma 3. And since 3 is colored in, I need a bracket. That's why last time when you said, hey, Mr. Harris, can I put those, instead of using those braces, could I use parentheses or brackets? And I had to say no. That's why. Different notation at the level you're in right now. Here's your number 3. I got the set of all numbers x such that x is greater than or equal to 8. Well, I'm going to have a closed dot on 8, and I'm going to have everything to the right. In interval notation, here's what it looks like. Since 8 has a closed dot on it, I'm going to have an 8 with a bracket on it, comma. And since I'm going to the right forever, I got infinity. And since it's an infinity symbol, it's got the parenthesis on it. So that's what your number 3 looks like. Number 4 is going to be different for you. You have not seen the set builder notation that looks like this. Here's what this says. In layman's term, it says this: x is between -1 and 3. X is between -1 and 3. It doesn't really look that way. This part's easy. X is less than or equal to 3. That part's easy. This part says -1 is less than x, but if you read it correctly, it says x is greater than negative 1. Well, here's what the graph's going to look like. On negative 1, I got an open dot. And on 3, I have a closed dot. And then I have all the numbers between. I like interval notation the best in this case because check this out. Here's what it looks like in interval notation. To show numbers between negative 1 and 3, not including negative 1, including 3, I'm going to have a parenthesis on the negative 1, comma, a 3 with a bracket on it. This means don't include negative 1, but include 3. So closed dot, bracket, open dot, parenthesis. And your number 5, I just threw in a graph of it just to give us some practice on how to write the set builder notation. This says I want all the numbers between 4 and 10. I don't want you to include 10, but I do want you to include 4. In set builder notation, here's what it's looked like. I got the set of all numbers x such that, so cool parenthesis, x such that. Whenever x is between two numbers, it will always look like this. Your lowest number will be there. These will always be a less than sign. X less than 10. And then I'm going to go back through and clean this up. Notice that the 4 is colored in, so I'm going to put a or equal to right there. You will always use a less than sign whenever you're talking about x being between two numbers, because it really says, it's hard to see right now, it really says x is greater than or equal to 4, but x is less than 10. In interval notation, I'd have a bracket, 4, comma, 10, parenthesis. There's what that's going to look like. Here's your number 6. Notice that I'm between two numbers again. Whenever you're between two numbers, it's going to look like this. Cool parenthesis, so the set of all numbers, x such that 2 is less than x, which really says x is greater than 2, in turn which is less than 10. I'm going to look, open dot, so I don't need to put underlines under either of those. In interval notation, I got 2, comma, 10. Since both of these are open dots, I got parenthesis, parenthesis. So there's what that one looks like. So what I'm trying to do here is just get you familiar with notation. Here in a little bit when I do the compound inequalities, that'll be the easy part. Interval notation, so set builder notation, what I need you to notice here is this. There's one piece of the graph here, and there's another piece of the graph there. Since there's two pieces of the graph, there's going to be two different pieces in your answer. So in set builder notation, it's going to look like this. X such that. And when I list this, I want to state the variable first. So it looks like these are all the numbers less than 5. Well, so one piece of it is x is less than 5. And then I'm going to put the word or. And then on this one, looks like I need all the numbers greater than 8, so x is greater than 8. Two pieces of the graph, two pieces of the puzzle. In interval notation, the same thing. I need two pieces. To do this piece here, all the numbers less than 5, it's going to look like this. Parenthesis, negative infinity to 5, parenthesis. Open dot on the 5, so I need parenthesis. And then I'm going to put the union sign. The union means along with or. And then over here I need all the numbers greater than 8, so parenthesis 8 to infinity. Open dot, so parenthesis. I'm going to the right forever, infinity. So there's what we got so far. Now I'm going to switch gears a little bit and kind of get to the main part of the lesson. If you will, on your notes, write these down where it says the meaning of the word and, the meaning of the word or. Mathematicians mess things up just a little bit sometimes. The word and means both statements must be true. In class, I gave an example where I picked two people, Mike and Simon. I'm going to give Mike $1 and Simon $1. Well, I give Mike $1, but I don't give Simon $1. Well, I lied then. So if I switched it around, I give Simon the $1, but I don't give Mike the $1. I lied. The only way I tell the truth is if I give them both $1. Also, on your note sheet, if you would, by the word and, put in parentheses overlap. That will help us here in just a second when we graph our solutions. Now, mathematicians mess the word or up. In real life, the word or means one of them happens or the other one happens, but not both. Take this example. I'm going to give Bill $1 or Simon $1. So I give Bill $1, but I don't give Simon the $1. I tell the truth. If I give Simon $1, but I don't give Bill the $1, I tell the truth. But if I give them both $1, I really kind of didn't tell the truth because I used the word or. But mathematicians think that's okay. So whenever you see the word or, we're going to say that one or both statements must be true. One or both statements must be true. And then also, if you would, on your notes, put in parentheses both or most. And I'll explain those to you here in just a heartbeat. Okay, so time to switch gears a little bit. Let's get to the compound inequalities and see if I can tie all of this together. Here's your example number 8. I got 2x is greater than 18 and negative 5x plus 3 is greater than or equal to negative 57. Well, your job, solve both equations. So let me divide both sides by 2, so I got x is greater than 9. And the word and on this one, let me subtract 3 and get negative 60. Let me divide both sides by negative 5. Since I'm dividing by negative 5, though, remember, I got to flip that sign. Negative 60 divided by negative 5 is a 12. You'll notice that on your class examples and on your assignment today, you're given two graphs. One of them's a working graph. One of them's the answer graph. You don't have to use both, but they're there for your convenience if you need to. I'm hoping in your head you could think this. I need all the numbers that's greater than 9 and less than or equal to 12. So I'm hoping in your head you're thinking 10, 11, 12, 9.1, 9.2, 9.3, and those would be the answers. Here's what it's going to look like in terms of a graph. I'm going to have a 9 here and a 12 there because 12 is greater than 9, and then we know the biggest number go to the right. I got x is less than or equal to 12. So I got a closed dot and everything in the whole wide world going to the left. X is greater than 9, I would have an open dot and everything in the whole wide world going to the right. Now, refer back to your sheet. Whenever you see the word and, I need you to think overlap. Need you to think overlap. Well, where do you see the black and the white graph at? Well, you see the black and the white graph between 9 and 12. So that's your answer. So on the answer graph, I'm going to come down here. I got an open dot on 9. I got a closed dot on 12. And I got everything in between. Now for your answer, in set builder notation, Whenever it's between two numbers, it looks like this. I got the set of all numbers x such that. And since we're between two numbers, it looks like this. 9 is less than x, which is less than 12. X is between 9 and 12. And then clean it up. 9 should just be a less than symbol. Since the 12 has a closed dot on it, I need to close that right there. So x is between 9 and 12, not including 9, including 12. In interval notation, I got 9, 12. A parenthesis on the 9, a bracket on the 12. And then we got it. So that's what it looks like. The hardest part today, guys, is the notation. Getting that notation down. Here goes your number 9. I've got 3x plus 5 is greater than or equal to 17. And, so as soon as I see that word and, I need you to think overlap. And negative 5x plus 12 is less than or equal to negative 24. Hey, first we just got to solve each of these. 3x is greater than or equal to 12. Divide both sides by 3, so I got x is greater than or equal to 4. And now come over here and solve this. I got negative 5x is greater than or equal to negative 36. We're going to divide both sides by negative 5, which means I got to flip the sign. So I got x is less than or equal to 7.2. Now, I'm going to go ahead and use the working graph and the answer graph again. If you can picture all the numbers greater than 4, but less than or equal to 7.2, and you could graph it and then write your answer, I'm good with that. But here's what it looks like. 4 is there, 7.2 is there. I have a closed dot on 4, so I've got that. And going to the right, I got closed dot on 7.2. Going to the left, where do those two graphs overlap? Between 4 and 7.2. So on my answer graph, I got 4 and 7.2, closed dot, and everything between. In set builder notation, remember, if x is between two numbers, here's what it looks like. The set of all numbers x such that 4 is less than x is less than 7.2. And then clean it up. Closed dot, so less than or equal to, less than or equal to. In interval notation, I got 4, 7.2, closed dot, so bracket, bracket. So there's what we got so far. I've got another AND statement coming your way, and then I'm going to switch gears to the OR statement. So once again, let's solve these. Let's add 3 to both sides and get 25. Let's divide both sides by 5 and get x is greater than 5. And 2x is greater than 16. X is greater than 8. So here goes my working graph first. 8 is on the right. 5 is on the left. X is greater than 5. So I got an open dot and to the right. I got an open dot and to the right. Hey, notice that the arrows are going the same way. So once again, in your head, I need you to think overlap. Where's these two graphs start overlapping? Well, they start overlapping right here at 8. So on your answer, that's what I'm going to show. 8, open dot, everything to the right. Hey, notice that I did not even list the 5. It's not part of my answer, so I don't want it on my graph. I will put an integer to the right of 8, which is 9, and to the left of 8, which is 7. Well, this time, since it's not between two numbers, there's going to be an infinity involved. So in set builder notation, the set of all numbers x such that, and I want all the numbers greater than 8, so x is greater than 8. So there it is in set builder notation. In interval notation, parenthesis 8 comma infinity. Hang with me, I got about 6 more minutes on this video is all. So there's your example number 10. I'm going to switch gears just a little bit to your number 11. I'm going to toss the word AND in there. Let's do the easy part first. I said the word AND, the word OR. Let's do the easy part first, solve each of these. So I'm going to add 2 and get 21. I'm going to divide by 3 and get x is less than or equal to 7. Or, let's subtract 3 from both sides and get 50. Divide both sides by 5 and get 10. Let's look at the graph. I got a 10 here with a closed dot on it. And since it says x is greater than 10, I'm heading to the right. 7 goes there. It's got a closed dot on it, and it's heading to the left. Now remember, mathematicians on the word OR, you can take one or both. Well, in this case, guys, this is my answer. I don't even need this graph. So that's my answer. But remember when we were writing the solutions, there's 2 pieces of the graph. There's piece number 1, there's piece number 2. So there's 2 pieces to this graph when I do it. So set builder notation. The set of all numbers x such that, let me list this piece here. Notice it's all the numbers less than 7. So to say that, I'm going to say x is less than or equal to 7. And then the word OR. Now let me come and get the other side. All the numbers more than 10. Well, x is greater than or equal to 10. So there's that part of it. In interval notation, though, there's 2 pieces to the graph, so 2 pieces to my solution. To do this piece, I need to go negative infinity to 7, bracket on the 7. The infinities always get a parenthesis, and then union, or along with 10 with a bracket to infinity. So there's what that one looks like. Here goes your number 12. Let's solve this real fast. I got 3x is greater than 6. Negative 3x is greater than 6. Divide both sides by negative 3 and flip the sign. So I got x is less than negative 2. Or 4x is less than or equal to 20 after I subtract 2 from both sides. Divide both sides by 4 and get 5. So let's look what the graph looks like. There's a 5. There's a negative 2. Closed dot on the negative 5 and to the left. Open dot on the negative 2 and everything to the left. Hey, notice that they're going the same way. And it's an OR statement. Whenever this happens, take the graph that looks like the most. The graph that looks like it contains the most numbers. Well, it looks like 5 on contains the most numbers. So here's what my solution is going to look like. I got 5, I got a closed dot, and everything to the left. Don't put that negative 2 on there. We don't need it. It's included in here. But do put an integer to the right and an integer to the left. In set builder notation, it's kind of easier. X such that, I just need all the numbers less than or equal to 5, so x is less than or equal to 5. In interval notation, I have all these negative numbers, so I got negative infinity, comma, 5, bracket on the 5, parenthesis on the negative infinity. So that's what that one looks like. Now I'm going to switch gears just a little bit. This is still an AND and an OR statement. Let me tell you what this really says. This says 2x plus 6 is between 18 and 28. I want to find all the numbers that I could double, add 6 to, and be between 18 and 28. My first question to you, is it an and or an or statement? Whenever you see something written like this, it's an and statement. And here's how come. It says two different things. Let me scribble this out since I can erase it. Well, here's what this part says. 2x plus 6 is less than or equal to 28. And, let me scribble that part out now and get rid of this part. And 2x plus 6 is greater than or equal to 18. So that's what it means. Solving is the easy part. There's two equations here, so we're just going to solve two equations at the same time. I need to get this x in the middle all by itself, kind of like we had on the other examples. So I'm going to subtract 6 from all three sides. 18 minus 6 is 12, is less than or equal to 2x. Less than or equal to 28 minus 6 is 22. So I'm just getting x by itself. I'm going to have to divide everything through by 2 now. If I do that, I'm going to get this. 12 divided by 2 is 6, less than or equal to x, less than or equal to 11. What's that say in layman's terms? X is between 6 and 11 with closed dots. So when I come down to the graph of it, 6, 11, closed dots, and between. In set builder notation, it looks like this. The set of all numbers x such that, since x is between this, remember, 6 is less than x, less than 11, always less than. Since they're closed dots, I just need to put parentheses under them. In interval notation, I got 6, 11 with brackets. So there's your number 13. Let's look at your number 14. I am going to skip number 15 just so I can tie it all together. I got negative 20 is less than or equal to 6x minus 4, which is less than 14. Or in layman's terms, 6 times some number minus 4 is between negative 20 and 14. So we just got to go to work on it. Let's add 4 to everything. So I've got negative 16 is less than or equal to 6x, which is less than or equal to 18. Let me divide everything through by 6. As you type this in your calculator, you're going to get negative 2.66666666. We don't want that answer. So backtrack and go negative 16, fraction key 6, and then second calculate, and your calculator is going to tell you that's negative 8/3 is less than or equal to x, less than or equal to 3. Layman's term, x is between negative 8/3 and 3. So here's what the graph looks like. Closed dots on negative 8/3 and 3, and everything between. In set builder notation, I'm between two numbers, so the set of all numbers x such that negative 8/3 is less than x is less than 3. And then clean it up. Closed dot, so I need or equal to, or equal to. In interval notation, bracket negative 8/3, comma 3. So there's what we got so far. Okay, hang with me, I got about 2 minutes left. I'm skipping example number 15 there, but I do want to tie this up together. So pause the video here in a second and write this down, or unless you can keep up as I go. I'm going to show you the 3 things that can happen during an AND statement, and then I'm going to show you the 3 things that can happen during an OR statement. During an AND statement, A and B can represent any numbers in the world, as long as A is less than B. So we could graph something and get greater than A, but less than B. If that happens, you go find the overlap. Where did that overlap occur? It occurred between A and B. So your solution is between A and B. Don't get caught up right now between the open dots and closed dot. The equation that you solve tells you what that is. You could have the graphs going the same direction. And it doesn't matter, guys, if it's going to the right or to the left. You just look for the word overlap. These things start overlapping at B. So this solution would be from B on. If they went to the left, they would start overlapping at A. So that would be your solution. Now, I did not do one of these during my original class examples, but you might do an AND statement, and then the arrows go the different way. So once again, you look for the overlap. If there's no overlap, there's no solution on an AND statement. So in this case, that or that. No solution. Now on an OR statement, let me show you the three scenarios that can happen there. On an OR statement, you might get one branch going that way and the other branch going that way. If you do, that is your answer. If your branches go opposite ways, that's your answer. Your branches might go the same direction. If they do, take the most that you see. Well, in this case, it looks like the most is going to occur at A on. If they went to the left, the most that you would see is B on. Now, I didn't do one like this in my example, but you could get all the numbers less than B. You might get all the numbers greater than A, and it's an OR statement. Well, if this happens, every number that you could think of is included. It's either included in my black graph or it's included in my white graph. If that happens, your answer is all capital RS, all reals. If you want to be cool, in interval notation it looks like this: negative infinity to infinity. Well, guys, that's the lesson that you missed, section 1.6. Of course, there's a worksheet for your homework, but you knew that was coming. So watch the video, take good notes. If you have any questions, come in and see me.